Hello, my name is Megan Boraas.
I'm Claire Willenbring.
And I'm John Pollock. This is our senior design project. We were tasked with creating a lightweight embedded system for a UAV for farmers to use to help with some population counting as well as crop health and expanding into other markets as well.
This was part of a research project with Nalgong, our advisor. So for an overview of our system, on the right-hand side we have a phone. As you can see, the phone does flight configuration. That determines where we're going to be taking our data. That is passed to our cloud service. In this case, we're using Google Drive. Google Drive will store all this information. The embedded system, in this case we're using a Raspberry Pi, will pull that information from Google Drive, and it will be using that information to configure flight data as we pull GPS data in and start capturing images. Once we're over the respective part of our field, we'll be processing that information, sending it back to Google Drive, which will then be pulled by the app and displayed.
So this is our UAV embedded system hardware setup. And so essentially we have our Raspberry Pi right here, and then we have our GPS modem, or 3G modem, our SIM5218E, which is then connected to our GPS dongle. And then this is also connected to our camera, which is taking pictures of a faux field on the other side here. And then for that we have a breakout board, which has an RGB LED, which kind of indicates when our GPS is ready and is getting locations.
Alright, so here we have our three different processes that we're running on parallel on our Raspberry Pi. On the right hand side here we have our GPS and image capturing module.
In the center we have our conversion script running. It will take the images captured in the previous script and convert them into red and black, followed by our last process on the left, which will take these converted images, run blob detection, and then upload the results to Google Drive.
This script on the left also does our flight configuration, which we'll show you in the app.
Right here I have the Raspberry Pi, and it is taking pictures of this faux field. To be able to take pictures, we have this dummy board, which will dummy out that we're getting GPS location because our GPS dongle doesn't work inside.
Here we have our three scripts about to start running. We have our blob detection script, which also pulls our flight configuration, now starting on the left screen. It is currently starting up and will pull its credentials like it just did. It has pulled and saved our configuration file locally for the other scripts to use. We will now start up the other two scripts. So we can see that the camera script is starting its initialization and is ready to start taking pictures. Our conversion script is now sitting and waiting to scan for new pictures. So now we are taking pictures and we are now starting to convert them. This process will take anywhere between 30 and 40 seconds. All the while we will continue taking pictures like we would in a normal flight. So we have just finished converting the image. As you can see, the blob detection has now found that there's a new picture for it to do blob detection on as well as upload, and our conversion script has now added the new images taken during the time it was converting the previous image, and we'll now start converting those. Now we stop taking pictures, simulating how our UAV has now finish its survey. At the same time, we can see that our blob detection has just finished. It was able to find 9 cows and it took just over half a minute. It has uploaded the result to Google Drive now. And we have finished converting another image as well. So now the left pane is working on uploading the image to Google Drive for the farmer to view if they enable that option. So as you can see, we just finished uploading the image to Google Drive. We now have a debug option enabled so we can show you what has happened. So here's the image with the cows circled, so you can see that it found all but one cow and I had one missed cow. This is just a current option to show what the program is doing in the background. From here, it would then continue iterating through all the different pictures and sending them up to Google Drive. So here we have our phone application for reviewing all of your results and setting up the configuration. We have 4 buttons. We have our Results tab, a list of pictures, the configuration, and setting a new flight. The new flight button doesn't actually change anything, it just creates a new folder for you on your Google Drive. Your configuration pane will then allow you to set your GPS start and stop locations using Google Map interface. So you'll zoom in to wherever your flight plan will start taking pictures. Say somewhere on the NDSU campus. And when you return to that page, you can now see that your GPS has been filled in. You will let it know what altitude you'll be flying at and what your average ground speed will be. Then you have a nice toggle button here to say whether or not you want to upload pictures. And when you are done, you will click Save Configuration, and it will upload that configuration to Google Drive. Once you have completed started a flight, you may go into the results page, where you can see it has number of cows found and number of pictures processed. Once you hit refresh, it goes to Google Drive, pulls down the configuration file, and you can see we have found 154 cows and a total of 8 pictures. You can then go to your picture list, and it will show you what pictures have been uploaded so far that you can view. You can click on those, and it will then display the picture for you so you can see what part of your field this was taken at.